Hi guys, so we're starting here our practice for the final QMB exam. So this is question number one. For question number one, we have here conduct a sampling experiment to compute the outcome of variables for each of the following scenarios with the information given. So we have the information part A, information part B, and we are also given some random numbers here. They are numbered from 1 to 10. The same thing for part B. And both questions you're asking for mean, maximum, minimum, and standard deviations. We already know this formula. So equals average, select the numbers, not the random ones, but the outcomes. Equal max, select the numbers, max, select the numbers, equal min, and the standard deviation formula. So one thing to notice here is that let me just highlight. There's a slight difference from question like the part A and part B. So in question part A, it's saying the outcome has a uniform distribution. And here in part B, the outcome variable has a normal distribution. So you see here that we're gonna have to calculate this kind of like the same thing for the outcome with the random numbers. The random numbers are different, but you do have the set of 10 numbers for each of the questions. But there's slightly difference because part A has a uniform distribution, part B has a normal distribution. So the first thing that we have to understand is what is the difference between them. And for that, I found this picture here that is easier to understand. So the first one here on top is the uniform distribution. So the things like run smoothly and in a uniform distribution. It means that the probability of something to happen is like uh, equal during the time. So for example, if you roll a die, every time you roll it, because it has 6 parts, it's the chance of getting a certain number is 1 in 6. So if you roll and the chance of getting number 1 is 1 in 6, the chance of getting number 2 is 1 in 6. The chance of getting number 3 is 1 in 6. So it doesn't change, and that's why it's uniform. The normal distribution here, it means that the number in the center is more likely to happen and the probability has a higher probability to happen. So, for example, babies in the US, they can be born like you can have preemies, being born like with a lower weight, and you have babies that can be born like with a higher weight, but usually they average to like 7.5 pounds. So it means that the probability of a baby being born with 7.5 pounds, for example, is higher in the center, like it's here represented. So you do have babies being born with other weights being lower or higher, but the one that is more likely to happen is the one in the middle, and that's the normal distribution compared to the uniform distribution. So that's something very interesting that I found online, and I think it helps us understanding the difference between the two questions. What are they talking about? So let's just put this here so it doesn't interfere with our calculations. So, okay, so moving forward to part A, we are going to read the question to see what it's asking for, the information that it's giving us. So it's saying the outcome has a uniform distribution, which we already know kind of what it is, with values between 17 and 54 minutes. So these numbers here are very important. 17, 54 minutes. Okay, so these are the values that we have, the range like from here, 17 to 54. Based on the random numbers given below, these are the random numbers. Use the uniform distribution formula to obtain a sample of 10 outcomes and compute their mean, minimum, maximum, and standard deviation. Okay, so we already know what we are gonna do. And one thing to notice here is that we are giving two numbers, right? So these two numbers, whenever we have the gap, the first number that is being given to us is going to be the letter A, and the last number is going to be the considered letter B, right? So I'm just going to write here so we don't forget that A equals 17 in this question, because like you can change 4 depending on the number that you guys have. So my B is equal to 54. Okay, so it's asking us to use the uniform distribution formula. So the formula, I'm gonna write it down here, formula equals, we're gonna use this formula here for the uniform distribution. It's gonna be A plus B minus A, close parentheses, and then times rand for the random numbers, open and close, because you guys know that that's the formula for the random numbers. Okay, so now we have it. So this is the formula, right? Put it in blue. Okay, so that's the formula that we're gonna use. So we have the random numbers here already. Because of that, we don't need to use the rand here. We're just gonna, instead of writing the formula, we're gonna select the number that is here next to us. So the outcome, you're just gonna type down the formula. So equals A, you can either like type the 17, or to be easier, like to drag down and avoid some mistakes, we're just gonna select the 17 I already typed here, plus, and then we have parentheses. Then we're gonna select letter B minus A again, and then times, instead of writing the rand formula, we're already gonna give the random numbers that were given to us. Okay, perfect. So one thing that we can do here is to drag down the formula, right? You can either do this to drag down, or you can just double click to drag down. However, there's an issue here, and the thing is that it's not working because the 17 is going to be dragged down and to other numbers with 54 too, so we have to lock the numbers. So to lock the numbers, we don't want to lock the random, of course. Otherwise, it's just gonna be selecting the first number, not the other ones. We're gonna lock A and B. So this section here of the formula, not this part. So to lock the numbers, what we can do here is just like add the dollar sign before and after the letter. So we can do it to all of them. Okay, and now we can pull it down. And there's also another way of doing it. So instead of you just like manually adding the dollar sign to each of the formulas, what you can do, you have to select them, and then if you're using a Mac, you can just select Fn and F4, and that's gonna lock the number for you. Okay, so Fn and F4 again, and same for the last letter A, F, and then F4. The reason why we're using Fn is because like I'm using the keyboard, and also it's a Mac. So the F4 would probably not work fine for your computer as well if it's the same for me. Okay, so we have the numbers here completed, and that's the way to calculate this formula. We already have all the outcomes. So now it's gonna be like the easier part to use this formulas here that we already know how to calculate. I'm gonna go ahead, equals average. Okay, open parentheses, we are always gonna be based on the outcome. Okay, equals max. Select the outcome. Equals min. Define the minimum. Select the outcome. The last one equals 300. And we're gonna use the last one, S. Select the outcome. Okay, and this section of the question is complete. Okay, so now we're moving on to part B. So part B, as we saw, it's the outcome has a normal distribution with mean of 15 and standard deviation of 3.66. So these are the numbers that we're gonna use. They are very important. Just gonna put them in red so it's easier to keep track. Um, based on the random numbers given below, typo. Use the normal distribution formula to obtain a sample of 10 outcomes and compute their mean, minimum, maximum standard deviation. So we're gonna calculate the same things here. We are also gonna add the formula here. So it's basically the same thing. However, we saw that in this part B, it's the normal distribution, as opposed to the first one that was the uniform distribution. So we remember that the uniform is kind of like here, and the normal is like the one in the center is more likely to happen. And because of that, the way of calculating it, it's going to be a little bit different. And one thing that is very interesting here is that in this first part, as you can see, like we input this information like A plus B, A plus B minus A times the rand. And in this case of the second question, we're already going to use the Excel built-in formula for that. So the formula, so first I'm going to write the formula here. Let me just copy this part. Okay, just copy here and of course remove this formula that we're not going to use anymore. The formula that we're going to use is the norm dot invert. So invert. So you can see here that in this formula, so it's asking for the probability, which would be probability, the random numbers, and then the mean and the standard deviation. So I'm just writing the formula. So I'm just gonna add a little thing here. So random number, comma, mean, comma, standard deviation. Okay, we close down. So this is the formula, right? And then we know that Excel has it built in. So we need the random number. The random here, they're given here. The mean is being given here, and the standard deviation is also being given here. I'm just gonna write them down. Mean equals standard mean equals. So this is 15. It's gonna vary by question depending on what you have. And my standard deviation is 3.66. So it's pretty simple. We're just gonna do like the same thing that we did before. We're gonna input the formula here. So A equals norm. Inverted. And then it's gonna require the random number that we're not gonna lock. And then the mean. So for the mean, we come here before, and then I'm just gonna do F and F4, so it's locked. And then comma, I'm gonna select the standard deviation now. Oh. And I'm gonna do the same thing to lock F and the dollar F and F4. Okay, and close the parentheses. And now I have the formula, so I'll just double click and it's being dragged down. Okay, perfect. Just gonna center them. You don't need to Now to calculate the mean, the maximum, and the minimum standard deviation, it's the same thing that we did before. So to calculate the means equals average, and then you just select the outcome. I'm just gonna copy and paste here so it's faster. So in this case, it was max. And then I already have it selected for the main equals main. Okay, and then standard deviation. We're gonna use the S because it's just like a sample. We're not dealing with a large population here, simple population. Okay, so our question is complete. We have part A and then part B. As it's required, we calculated the outcomes for the various scenarios. We understood the concept of uniform distribution and the normal distribution. We also applied the formulas for mean, maximum, mean, maximum, minimum, and standard deviation. We used the random formulas instead of the rand. And if you go like to the last one, you can check that all of them are complete. Thank you guys.